All right, let's begin. Shh, shh. Let's begin. Now today's lesson. Today's lesson is just continuing on yesterday's lesson on normal distribution. The aim is I'm just going to do a couple examples so that you can see the method and what you're applying, and then I'm going back to the two exam questions that I told you to look at yesterday, but I'm going to guess that not many have looked at it. I know it's there, but I do want to go through it just to explain it because it isn't hard. Normal distribution, binomial distribution, continuous probability, and discrete probability, they're not hard. Okay, so I do encourage you to draw, especially when it comes to normal. I find that normal is probably one of the easiest probabilities that you can do. It's symmetrical, it's easy to look at. I don't think it can get too hard. And so I do encourage you to be able to do 16C, and that's what I'm focusing on today. Okay, so let's have a look. 16C, I'm just going to look at this problem here. I chose 16 as the last three questions because, you know, if you understand the theory, then you can do all questions really. Okay, so it says the 68 to 95 to 99.7% rule. So if you've forgotten, I gave you yesterday three properties that you needed to know, and it was if you had it was X if it was between the mean, one standard deviation below the mean, and one standard deviation above the mean, okay, then it is approximately 68%. Okay, so what am I saying visually? Visually, I'm just saying if the mean was here, one standard deviation below, so one standard deviation below, and one standard deviation above, so one above, one below. This is approximately the area. The probability is approximately 68%. That's all I'm saying. Okay? So, whoops, let's go back. And then you got your 95, which is 2 standard deviations, and then your 99.7 is 3 standard deviations above or below the mean. Okay? So that's what I'm I want to just re-emphasize there. So now the question tells you, it says it's approximately the percentage of a normal distribution, not a standard normal. So any distribution, the mean doesn't have to be at 0, it doesn't have to be at 0. It's just saying that 68% of the data generally falls under one standard deviation, 95 is 2, 99.7 is 3. Yeah? Now it tells you if Z is a standard normal, which implies that the mean is 0, standard deviation is 1. Find corrected 2 decimal places for negative A and A, so the probability of Z distribution is 0.68. What is that saying? All it's saying is, imagine you have this graph, it's a standard normal, so that means mean is 0, standard deviation is 1, but all they're just saying is if it's exactly 0.68 between a certain point, that is negative A, and a certain point, that is A. That's all they're really saying, and they're saying that this area is 0.68. And now logically we know the answer is approximately negative 1 to 1. Okay, but they want you to find the actual value to it. So for negative A, how do you do that? If you remembered what I taught you yesterday, I showed you that in order to find these values, it's the inverse normal. If you're finding the probabilities, then you use normal CDF. But in our case, we're working out the values of X or Z, then you're going to use inverse normal. There's only two functions that you had to use for this chapter. You either use normal CDF to find out the probability, or you use inverse norm to find out the value. That's it. Okay, so in our case, we're trying to find out the value. So this is how, whoops, wrong direction, this way. That means we know it falls under one standard deviation. If we drew out, we knew it's 0 and 1. I've drawn out the problem for you. This is, how do I remove that bar? Why is there that bar there? How do I hide it? Anyone know? Maybe I'll do this. I don't know. I don't know. Let me just try to remove this. Oh well, probably doesn't matter. Alright. Well, you can see what I did here is I just went inverse normal. But I want you to pay attention to the values I've used. I used 0.16, 0, and 1. 0 is your mean. 1 is your standard deviation. Why did I use 0.16? This goes back to what I was saying yesterday. So I drew the picture for you before. I'll draw it again. Whoops. I drew the picture for you. I said, this is it. We're trying to find negative A to A. This is 0.68. Why did I use 0.16? Which is 16%. Where am I getting 16%? Why am I using this? John?
You want the area like either to the right of A or left of negative A.
Yeah.
And you know that 1 minus 0.68 would be 0.3. Use both areas, left and right. But you only want one, so you opt that.
Yeah. Exactly. And one of the things I said yesterday was when you use inverse normal, it calculates the area from left to right. So it only calculates from left to right. And we want, if I knew this is 68%, that means this area and this area has to add up to 32. If they both have to add up to 32, well, since it's symmetrical, half of 32% is 16%. That's why I know this area right here has to be 16. If it only calculates from left to right, then it will calculate the value for you from left to right, which is here. Okay, so that's why I used it as 6.16. Because if you put 68, what it will do is it will calculate from the left all the way to the right until you make 68%, and it'll tell you what value it is. But what we know is from negative A to A, it's 0.68. That's why you can't just put in 0.68 as the answer. You have to be careful. That's why I'm telling you to draw the problems. These are typical problems that you get in your exams, that if you're looking for a particular, they sometimes will ask you to find out the area or the value for this. See, what you would then have to do is then 1 minus 16 or 1 minus 0.16. You'd have to say 100% minus 16% will tell you the area from here all the way to this point. See, if this is 16 here, and you only calculate from left to right, well then, how much of a percent is on this side? 100 take away 16 is 84. So I know that this side must be 84. So if I wanted to work out the value of A, I would then say change this to 0.84, because it calculates from the left to the right. And I will get to A, and it'll tell me what the value of A is, because it only works from left to right. Okay, so that's the one key that you have to pay attention to. It's always left to right when you do the inverse normal. Okay, but because we know it's symmetrical, if we know that from the mean, it's from this value, it's standard normal, because remember it's standard normal. So 0 goes negative 0.994, then obviously to the right it will be positive 0.994. Okay, because it's the standard normal, you don't have to actually calculate A. If you know a negative A, then you know positive A. Okay, so answering that question. Man, I really don't like that bar. That bar's in the way. Oh well, I guess I'm going to have to do this then. Here we go. Cool. So area of the left hand. So for part B, same concept. Part B, I'm just trying to show you, if it says from negative B to B, it's 95%. Same concept again. If this is your data, this is 0, negative B, and this is B, and we know that the data is 0.95, which is 95%. Well, it means that on your both left and right, you've got 5% left over. Since it's symmetrical, that means this has to be 2.5, and this is 2.5. So if you want to work out what negative B is, you just work out from left to right, inverse normal. Area is 0.025, because that's 2.5%. 0.1. And that will tell you, it will calculate the value from the left to right, and it will tell you what negative B is. If you know what negative B is, you know what B is. And that is only because this is a standard normal. It has to be a standard normal problem for you to make that assumption. Okay? So you know that 0 to negative B, so therefore 0 to B is the same distance. Okay? And so you answer the question, you just carry on the areas 2.5%, so I did exactly that. So therefore I know B must be 1.96. Okay, so 1.96 on the right, 1.96 on the left. Easy. So that's question 16. So the only thing I was trying to teach there is be careful when you're using inverse normal, areas from left to right. Okay, if you put in 0.68 and you got the wrong answer, that's why. Okay, because when you're always working from left to right, it doesn't do intervals for you there. Okay. All right, so let's have a look at the second question. So I only picked out 3, 16, 17, and 18. 18 you're going to do, because I'm going to show you how to do 17, and then you're going to demonstrate what you understand. If you can do 18, then you can have a look at the problems I gave to you yesterday for your exams. If you understand it, you should be able to do it now. Okay? So let's have a look at 17. It says, given that x is normally distributed, keyword. It didn't say standard normal. It said normally distributed. So it means I know the mean is not 0, and I know the standard deviation is not 1. And that's what they told me. Mean is 22. Standard deviation is 7. So I can start off by saying, all right, mean is 22. Standard deviation is 7. Let's answer the first question. For every one of these, I want you to get in the habit of drawing it. It's not a hard problem. So start drawing these. I know it's tedious, but once you get good at it, you don't have to draw it. But to start off, draw it. Draw the problem out. So the question is, you got A, find the probability of x less than 26. If I were to draw this problem, it's a bell curve. I know that the mean is at 22, standard deviation of 7, so that means 7 above is 29 and 7 below is 15. Yeah? That's my current problem. Now they're saying, find the probability of x less than 26. Well, 26 has to be somewhere between 22 and 29, so I'm going to say 26 is here. What are they asking for? They're asking for a probability. Probability is the area under the curve. So I'm just looking out for that. And it just so happens that it's from left to right. So A was the easiest problem that you could do. That's a textbook question. You're just looking for the probability from negative infinity up to 26 for your function, which we don't know, f of x dx. That's what you're doing for. Okay? In our case, whoops. In our case, we already got, we know that draw the problem, and that's simple normal CDF. I told you to find the probability, you're just using norm CDF, or if you're finding out the value, it's inverse norm. 2 functions for this chapter, not hard. So I answered the question. I said from negative infinity up until, so negative infinity all the way up to 26. If I know the mean, I know the standard deviation. There you go. That's my probability. About 72%. Okay, 72%. That's 72% of the data is there. Less than 26. So, answer the second question now. 25 to 27, same thing. If you think about the graph, same thing. It's just asking if this is 22, 15, 29. They're just asking find the area 25 to 27. So 25 is somewhere here, 27 somewhere there. That's all you're looking for. So same thing. That means your integration is from 25 to 27 of f of x dx. In our case, we don't know what f of x is. We just know that it's a normally distributed function. That's why you use norm CDF. So same thing. The only difference is I'm just changing these 2 values. Now this is now going to be 25 to 27. Okay, so if I do that, same thing. 25 to 27. Voila. About 9.6%. Okay? Which makes sense. It's a small portion. So it makes sense to be about 9.6%. Let's have a look at the third one now. Okay, now this is a typical one. That was one of the questions I put up on the exam as part of the exam question, exam 1. It looks scary, but it's not. Let's go through this together. Okay, let's have a look. Whoops. Did I put animation? No, I didn't. First one says, probability, and just treat this as a conditional probability. It says x less than 26. This is A. Given that you've got x is already between 25 to 27. This is B. Now we know through conditional probability from chapter 13, probability of A given B is when do they both occur? So meaning where do they intersect, what do they have in common over what's already happened? Well, I already know it's between 25 and 27. Now if you draw out this problem, it's very simple if you think about it. Okay, it's saying when does 25, why did I have 25 to 26? Where did this come from? If you think about the diagram, it's very simple. I said it's mean of 22, 29's here, 15's here. if I knew that 25 to 27 has already occurred. So 25 to 27 has already occurred. So I've already got this area. I'm asking, what's the chances of me between 25 to 27 that I'll get something less than 26? That's what it says here, less than 26. What's the chance of getting less than 26 if you already know you're choosing between 25 to 27? So I can already say to you, well, less than 26 is here. So therefore, I'm looking at that point. That's the chances of it happening. That's where they both overlap. That's where your intersection is. When you say, when does event A intersect with event B, you're just saying, when will you have x less than 26 and you are between 25 and 27? Well, clearly you're just between 25 and 26. That's why I wrote this. That's why I wrote the probability, the area you're looking for is just 25 to 26. This is still the same. Probability B is between 25 and 26. So if you know that, if you understand that, plug in your computer into your laptop. I mean, not laptop, into your calculator. And if you're doing your calculator, this is all you're doing. You're just saying, I want to find the area between 25 to 26, given you got the mean and standard deviation, and divided by what you already have, 25 to 27. Voila, 52%. Which makes sense, because if you look at my diagram, it does look about 52%. 25 to 26 is about half of that. So between 25 to 27, it does look like 25 to 26 is about half of it. It does make sense. See that? So if you draw the problem, try to understand the problem first. If you look at the equation, yes, it looks scary, but it isn't. If you draw the diagram out, it makes a lot of sense. Okay, so now I'm going to do the last problem, because I'm trying to teach you concepts here. I'm trying to get you to relate the diagram to the problem. I'm going to do E. And the reason why I chose E is because it says greater than K. Whereas this one is less than C, it's much easier to do. That's why I'm avoiding D. I'm going to do DE so you can see what I'm doing here. Same thing, draw the problem. Let's draw the problem. So you got bell curve 22. That's your mean. It says now, find X. So X is along this X-axis. Find X so that it is greater than something. Greater than a number. I don't know what the number is. It could be greater. It could be 23. It could be 15. It could be 7. But what I do know is the area greater than this number will be, 90%. Now logically, 90%, well, it has to be greater than some number. So it wouldn't make sense to be greater than 22. Because 22, this is half of the data, that's already 50%. So that means that number has to be somewhere on the left-hand side. So there's no, I could just say it's here. Somewhere here, I know it needs to be an extra 40% here. 40 plus a 50, that gives me 90. Question is, what is K? So remember I said there's only two functions in this chapter. You either do normal CDF to find the probability, or you use inverse normal to find out the value. Now, what's the problem with using inverse normal that I showed you? It only works from left to right. I can't get from K to all the way up and say that's 90%. So it wouldn't make sense if I wrote inverse normal 90% 0.9 and I tell you the mean and standard deviation. It won't work. See, if you do that, that's calculating from left to right 90%. It gives you a different K value. We don't want that. So in order to do that, you need to know, well, if this is 90% on the right-hand side, well, then how much is on the left-hand side? Good, 10%. So therefore, this has to be 10%, which is 0.1. So the only problem that you change is instead of 0.9, it's 0.1. You know the mean, you know standard deviation, 22, 7, done. That will tell you the value from left to right, what K should be. Okay, that's what you need to understand. So draw the problem, analyze the problem, don't jump into it. Don't think that, you know, I'm just going to skip all the steps. I'm going to write down the equation. You're more prone to getting a mistake, especially for the exam questions. Okay, so having said that, if I do that, so in this problem here, if you draw out the problem, and you knew on the left is 0.1, so that's all I did. Inverse normal, 0.1, that's the area I'm looking for from left to right, and the value is 13, which makes sense, because remember the median, the mean was 22. And I said it had to be a value on the left-hand side, so of course it's 13. It's smaller than 22. So from 13 onwards, if I had the graph, all it's just saying is 13 is here. The area greater than 13 will be 90%. That's all it's telling me. Okay? So I hope that you're starting to feel, you're getting the idea of what normal distribution is. Because if you do, this is question 18, exactly the same. I'm going to give you 5 minutes to do this. Use your calculators. Because once you can do that, then the exam questions that I gave you yesterday, it will not be hard now. The ones where students got 37% and 31%, they shouldn't be getting that. It's a very simple question. It's a textbook question. So you should be able to do it. All right? So have a go. I'm going to give you 5 minutes to do this, and then I'll give you the answers. Otherwise, you can check your textbook. The textbook has answers, and then we'll go to the exam questions, and I want you to give it a go this time now. Okay? Yes, you can. Grab a few while you're at it too. Grab any calculators ready. 5 minutes. Let's see. It's now 11:21. 11:26. I'll come back. Yes, you may. Did you charge it overnight?
I charged it because I didn't get my steps up. I already have a move as my brand. And then so it's getting better since yesterday morning. Still not really yeah, I'm not gonna listen.
2 minutes left. Minute left.
That's what I'm saying. You can't get 42. That's like 4,000.
All right. It's a bit longer than expected, but hopefully you got your answers. Check your answers. Check your answers. Mainly the last one, if you use the property where you knew mean plus or minus 2 standard deviations, you're very close to it. But because it's equal to 0.95, you had to make sure you still use your inverse normal in your calculator. So it is close to 9 and 11, but to answer the question appropriately, it should be done correctly. So all I'm just saying is, we know that this is C1, C2, you know this is 95, so therefore on the left, it's 2.5% from the left to right, and then obviously from left to right to C2, that is 97.5% because you got 2.5% on this side. So 100 minus 2.5%, whoops, 100 minus 2.5% gives you 97.5. So you should have done inverse normal, where the area is 0.025 for C1, and then C2 should have been 0.975 to find out C2. And that's how you would have got 10.98 to 9.02. Okay? So if you got most of this correct, actually, can I get a show of hands who got most of this correct, please? Hands up if you got 1 wrong. Hands up if you got 2 wrong. All right, good. Excellent. Now I want you to have a go with this one. 2010. First one, all of you should get that correct now. Now, just pay attention. It's x greater than 5. That's the key step. Be careful with what they're talking about. They always do that in the exams. They don't do less than all the time. They always do greater than to catch you off guard there. So A and B now. Have you understood? Draw the problem. Draw the problem out and look at what they're trying to ask for. I want you to draw the problem, draw it out, analyze it, because it's just a normal symmetrical shape. And you only got two functions. You either find a probability or finding a value. So you can't go wrong. It's only a couple options. You can't go wrong here. Okay, so have a go with this. It's 3 marks, exam 1, and there's another one for you to try as well. Same thing. Standard deviation. It's a normal. Doesn't matter. All right, let's go through the answers. Let's have a look. Both of these problems shouldn't have been hard at all. If we look at it from this perspective, normally distributed. It tells you it's normally distributed. So keyword again, it's not a standard normal. So it doesn't have mean of 0, it doesn't have standard deviation of 1, which is true. Okay? Now the only difference here is they told you the variance. They didn't tell you what the standard deviation is. You know what the mean is. But don't forget, standard deviation, I told you, it's the amount of error. In variance, it's squared it. So the only way to get the actual error is by square rooting it. That's the theory I tried to explain in chapter 13. So you didn't have to memorize this. You would have known to find out standard deviation, it is the square root of variance. And so therefore, square root of 9 gives you 3. So you now know standard deviation is 3. Okay? So from there, we can start answering the question. It says, let z be the random variable with standard normal. Okay, so we're now talking about z values where the mean is 0 and standard deviation is 1. Okay, that's what they're talking about. Now they're saying find the probability of x, not z, x greater than 5. So if I draw this problem, it's just asking this. If I knew the mean was 5 and standard deviation is 3, which is 8, and this is 2, logically they're just saying x greater than 5. You didn't have to do much calculation. It was very logical. Right there, if I drew the problem, oh yeah, I guess x greater than 5, you drew the problem, is clearly 50%. And clearly a lot of students got this correct too, because it made sense. If you draw the problem, it's very logical. Now, the second problem, which is this one, which I'm more interested in, x greater than 7 is equal to what for z less than b? See, the only confusing part is one says greater than and one says less than. But if you draw the problem, if it's a z distribution, I know the mean's 0, standard deviation's 1, that's -1 there. They're just asking, if this is 7 is somewhere between here. So 7's there, and if I just rub all this off, 7 is this. Greater than 7 is this area. I'm going to call that area, I don't know, let's call it T for Mr. Tran, okay? T. So I don't know what the area is. It's T. Well, all they're asking is, okay, so this area of T needs to be equal to the probability of Z less than a certain number. So if T was, I don't know, let's say if it was 20%. If it's 20% above, then I just want less than some number in the Z value to also be 20%. That's all I'm asking. I just want the number to also be 20%. That's it. The problem is I just don't know what the area is just yet. But once I figure that out, to find out B, it's very easy. It's just the inverse normal. Okay, so from here, how do you find out the area greater than this point? Well, it's pretty straightforward in the sense that x greater than 7, you can find out the area x greater than 7. Okay, so it's just like from 7 to infinity, you can work out the area there. But what I want to show you is, what you can see is, all they're using right now is, you know the mean, then you know the standard deviation, and you know the x. So you can find out your z value. Because it's a transformation, you just want to know what your z value is. You see? Because, think about it, it's symmetrical. From here, if I said this is 7, greater than 7 gives you a certain area. Let's say it was T. That means less than a certain value, whatever this is also T. Oh, how do I go back? Well, no. There we go. True? So symmetrical. So greater than 7 is T, less than a certain number is T. So if I compare this to a Z normal, where this is 0, I don't care what this is. This is what I'm looking for. I'm looking for B. So all I'm asking is, since it's normal, because you know it's a standard normal, that means whatever goes up is exactly what goes down. So if I go up by 2, then down by 2 is the same thing. It's the same area. So all you had to do was just figure out, oh, well, what is 7 as a Z value? Because if you know what 7 is as a Z value, then B is just exactly the same except it's negative. That's the only difference. So all they did was they took, to find out Z is the transformation. 7 minus 5, which is your mean, divided by your standard deviation, is 2/3. So what does that mean? It just means if Z was 2/3, the area above this, so probability of Z greater than 2/3, is exactly the same as probability of X greater than 7. That's all I'm saying. And because it's a standard normal, if it's symmetrical, if it's 2/3 up, then the same proportion would be 2/3 down. So B must be negative 2/3. Logically. That's why I said draw the problem. If you try to do it mathematically, it's going to be hard. But if you think about the problem, draw it out, it's very straightforward. The area down here is exactly the same as the area up here, which is exactly the same area as up here. We're just saying what is 7 equivalent to in terms of Z values. And we know it's 2/3. And the nice thing about standard normal is you've got a mean of 0. So whatever you go to the right is the same as the amount that you go to the left. So the answer, so the answer has to be negative 213. And if you look at the difference in terms of the scores, it was 70-something% for students to be able to do that. And look at the percentage for this one. It's like 31. How crazy is that? That's a simple concept. It was just 2 lines. And it's just properties and applying that understanding. Draw the problem. Okay, so take a step back and draw the problem. That's all they're trying to describe here. Just trying to describe 2/3 up is the same thing as 2/3 down because it's the standard normal. Okay? Now that you have that profound knowledge, try this one again. This one, I think it was 34% students getting the second part correct. And this is a textbook question. It's very similar to what you did with question 18. No difference. Okay, have a go with this one. Remember, it's exam 1, no calculator. No. Exam 1. Yep.
Okay, so in this case, so you're trying to find this area here. You can skip why you change that? X, right? Okay. Oh, so then go
Bell's about to go, but this first part is very similar to the last question. Hopefully you got it correct. I'm going to show you the answer there. Same concept again. You can find out your Z value and then you'll know what B is because of the symmetry. So it's exactly like the last question I just gave you, the one I just taught you. So 50-50 on that one for most students. Same thing again, I'm just saying draw out your problem and greater than 3.1, which is this, is the same thing as in a Z value less than a certain value. It's the same thing. So this B, negative B is the same thing as B, just find out what B value is. Okay, find out what this is in terms of Z. And how you find that? X minus mean divided by standard deviation, that tells you the value. That's why you know it's -2. Yeah, same thing as before. Now, the right hand side, same thing. You have to find out the area first. Draw out the problem, because once you know the area, 84%. Wait, is that right? No, sorry. Less than 1 is 84%. So you know the top is 16. And then from there, you can work out your values. Same thing. Okay? Have a go at this problem again in case you draw out the problem. Oh, draw out the problem. Draw out the problem.
So it's actually only 13.
Oh, I do know why. I do know why. Logically, is because the time frame. So we are now still teaching continuous. So we're going to assess for the next 2 weeks. You got half of
So I've been for these questions, I've been integrating on the calculator with that massive equation. It's been fun.
It's working?
Yeah, it's working.
And that's the theory.
The normal, like the function itself is doing exactly what you're doing. I've just done it. Yeah, but you see, that's why I wanted to teach the theory, so that you understand that when you use the function, it makes sense what you're really doing.
Right.
Because once you know it, then it'll be easy. It's not that. I don't think so. I mean, I look at it and I'm like, what was hard about it? Symmetry.
This one I didn't quite get. This is the only one that I was.
Really?
Yeah.
So, all right, let's go through the problem again. Wait, what time is it? Is it lunch? Oh no, I've got class. Damn.
All right.
I got class. How about start of lunch or something?
Okay. Yeah.
Yeah. I'll have a look at the problem in the meantime.
Yeah.
And see if you understand it. I'll come to you again, and if you understand it, then I won't explain. But if you don't understand it, I'll explain.
All right. Thanks, Ed.
No worries.